Ever wonder what stops, the entire world from just falling apart? Seriously. Today, we're going to dive into the ultimate cosmic superglue that holds literally everything together, from the salt on your table to the water in the ocean. Yep, we are talking about chemical bonding.
No, really, just think about it for a second. What is holding the atoms in your chair, your phone, heck, even in your own body together? There's this invisible force that keeps everything from just poofing into dust. And that's exactly what we're going to break down today.
So what is it? Well, the answer is the chemical bond. It's this incredibly powerful attraction between atoms that really does act like the universe's superglue. And, this glue comes in three main flavors that we're going to check out: ionic, covalent, and metallic.
All right, first up, let's tackle ionic bonds. The best way to think about these? It's all about giving and taking.
Seriously, just picture it like a simple story. It's a transaction, right? You've got one atom, let's call it the giver, that donates an electron. And then you have another atom, the taker, that just happily accepts it. It's a super straightforward exchange.
Okay, so how does this whole transaction actually go down? Well, it's basically a clean three-step process. First, you have a metal atom, our giver, and it loses an electron. This leaves it with a positive charge. Then a non-metal atom, our taker, swoops in and grabs that electron, which gives it a negative charge. And finally, well, you know what they say, opposites attract. They pull together like tiny magnets and bam, a super strong ionic bond is formed.
And listen, this isn't just some abstract theory in a textbook. This exact give and take is happening in the salt you put on your fries. A sodium atom gives an electron to a chlorine atom, and boom, they lock together. What do you get? Sodium chloride, or, regular old table salt.
Okay, moving on to our second type, covalent bonds. So if ionic bonds are all about giving and taking, covalent bonds, well, these guys are all about sharing.
Yeah, think of it this way. If an ionic bond is a quick transaction, a covalent bond is more like a partnership. Instead of one atom straight up giving an electron away, two atoms decide to cooperate. They share their electrons. It's a much more, balanced deal.
So let's make this super clear because it's the most important difference. For ionic bonds, the key word is transfer, 100%. But for covalent bonds, the magic word is share. It really all just comes down to what those electrons are up to. And what's the result of all this friendly sharing? You get these incredibly stable molecules that make up, well, pretty much everything around us. The most famous example? Of course, it's H2O. You've got two hydrogen atoms and one oxygen atom all sharing electrons to form one single molecule of, well, water.
All right, now for our third and final type. And get ready, because this one is, well, it's completely different. Let's talk about metallic bonds and what's called their free-flowing sea of electrons. Okay, so the main idea here is that inside a piece of metal, the electrons aren't stuck to any one single atom. They're delocalized. And that's just a fancy way of saying they can roam around totally freely, creating this thing that scientists literally call a sea of electrons.
The best way to picture this? Imagine a community swimming pool. The positively charged metal ions, those are like the people, just kind of floating around. And the electrons, that's the water itself, just flowing freely all around everyone, holding the whole thing together. Pretty cool, right?
And this unique structure has a huge real-world payoff. That free-flowing sea of electrons, that is exactly why metals are such amazing conductors of electricity. I mean, an electrical current is just moving electrons, and in a metal, they're already free to move around wherever they want.
Okay, let's pull all this together for a quick summary. So when we talk about what the electrons are doing, ionic, they're transferred. Covalent, they're shared. And metallic, it's that communal sea. And what about the elements involved? Easy. Ionic is a metal plus a nonmetal. Covalent is just nonmetals. And metallic bonds, well, obviously that's just for metals.
All right, now for the part I know a lot of you have been waiting for. We've got the concepts down, which is great, but how do we turn this into acing the test?
Look, if you're cramming and you can only remember a few things, remember this. Ionic is transfer. Covalent is sharing. Metallic is a sea of electrons. Seriously, if you can just visualize those three key ideas and remember which types of elements go with each one, you are going to be in fantastic shape for any exam.
So let's end with a final thought to chew on. We've seen that all these bonds are really just different ways that electrical forces make atoms stick together. So how can that same basic force create something as incredibly hard as a diamond, and at the same time, something as fluid as a puddle of water?
The whole secret is hidden in the unique strength and structure of these bonds. Pretty amazing when you think about it. Thanks for tuning in.